this video, we will discuss about separate black and white balls. First, let's understand the question. There are n balls on a table. Each ball has a color black or white. You are given a zero-indexed binary string S of length n, where 1 and 0 represent black and white balls respectively. In each step, you can choose two adjacent balls and swap them. Return the minimum number of steps to group all the black balls to the right and all the white balls to the left. So what they are saying is that in the question, we are given a string S which contains only 0 and 1. That means we are given a binary string. Here 0 represents white balls and 1 represents black balls. In one step, you can take two adjacent balls and you can swap them. Right? Now, after swapping, you need to group all the white balls to the left, or we can say all the zeros have to be grouped to the left and all the black balls or all the ones towards the right. Then whatever is your minimum number of steps to satisfy these conditions, that you need to return as your answer, right? So if in this case we see that this is a white ball and this is a white ball, these are already in the left, right? White balls have to be grouped towards the left. Then these are your black balls. Now this, if you see, this is a white ball. It is in the middle. Ideally, it should have been here, right? So we will have to move this 0 towards here. And how are you going to move it? First, you will swap this and this, then 0 will come here. Then you will swap this and this, and then you will swap this and this, right? So if we write here, when you will perform first swap, then it will something like this, right? Then in the second swap, you will swap these two. So then your string will become like this, right? Now when you will perform the third swap, then you will swap these two, right? So 0, 0, 0, 1, 1, 1, 1, 1, 0, 1. So now if you will see that we have successfully moved this 0 towards the left, right? Now if you see here, which is the next 0 that we should move towards the left, it is this one, right? And how are you going to move this 0 towards the left? By swapping this with all these ones, right? So what will happen is, first we'll swap these two. So it will be 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, right? Then in the next swap, you will swap these two. So it will become 0, 0, 0, 1, 1, 1, 0 and triple 1, right? Then you will swap these two. So it will become 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, right? Then you will swap these two. So it will become 0, 0, 1, 0, 1, 1, 1, 1, 1, right? Then you will swap these two. Now it will come towards the left, right? So now if you see here, there are no further zeros which we need to move towards the left. So now in all these steps, there are few things to notice. Now what are those things? So if you see here, we only focused upon moving the white balls or moving the zeros towards the left, right? We didn't focus on moving the all the ones towards the right. But when we were focusing on moving only the zeros towards the left, eventually we were able to move all the ones towards the right also, right? So whenever I am moving all my zeros towards the left, all my ones will be automatically grouped together towards the right. Then that means I can focus only upon moving all the zeros towards the left, right? So that is the first point. Now what is the second point? So if you see here, we have moved these two zeros towards the left, right? Now we need to count the number of swaps that we had to perform for these, right? So if you see here, for swapping this 0, or we should say for moving this 0 towards here, how many swaps did you perform? This one, and this one. So it will be 1, 2 and 3. So total 3 swaps you perform. So for moving this 0 towards the left, we had to perform 3 swaps. Now why we had to perform 3 swaps? Because before this 0, there were 3 ones present here, right? So to move this 0 towards here, we need to shift it towards the left one by one, and because there are 3 ones, we need to shift it 3 times, right? So if you see here, we had to shift it this 0 towards the left here, right? How many swaps did we perform for this? So 1, 2, 3, 4 and 5. So total 5 swaps we performed. Now why do we had to perform 5 swaps? Because before this 0, we had a total of 5 ones, right? So we had to do 5 swaps in order to move this 0 till here, right? So what we are saying is, for moving any 0 towards its left, whatever are the number of ones present before this 0, that will be the number of swaps that you have to perform over this 0 to move it towards the left, right? Because for this 0 we had 3 ones towards its left, so 3 swaps. Before this 0 we are having 3 plus 2, 5 ones towards its left, so we had to perform 5 swaps, right? So can we say that if we start from the starting and for every 0 we keep a count of how many ones are present before that 0, right? And whenever we encounter any 0, we will add the number of ones in our swap, right? Can we say that? So let's remove all this. So what we'll do is, we will take two variables. One will be the swaps, which will be initially 0, and the other will be the count of black balls, right? Or we can say the count of ones. One is denoting black balls, right? So that's why other variable will be the count of black balls, which initially is 0. So now we will check for every character in our string. So for auto C in S, we'll check that if this character is a 0, that means is it a white ball? If it is, then in the swaps, we will add the black count, which is the number of black balls, right? Else, if the character was 1, that means if it was a black ball, in that case, we will increment our black count by 1, right? And at the end, we can return our swaps, right? So if you see here, when you will be at this white ball, your black count will be 0. So in swaps, 0 will be added. Then when you will be at this 0, then also black count is 0. So in the swaps, 0 will be added. Then for this one, your black count will be incremented by 1. Then for this one, your black count will become 2. For this one, it will become 3. Then when it will come at this 0, then in your swaps, black count will be added, which is 3. Then for this one, the black count will become 4. Then for this one, black count will become 5. Now when it will come at 0, in the swaps, the black count will be added, which was 5. And earlier swaps were 3. So now total swaps will become 8. Now when it will come at this one, your black count will become 6 now. But now our loop will get completed. So the total number of swaps that we got is 8. Right? So now let's code it out. We'll create two variables, long swaps equals to 0 and black count equals to 0. Why we have created long? Because we need to return long, right? Then we'll iterate for every character in the string. So for each character in our string, we will check that if C is 0, then we will add the black count in the swaps, right? So swaps plus equals to black count. Else what we'll do? We will increment black count by 1. And at the end, we will return the swaps. So now let's run this. So in this, if you will see that we are only looping once in our string, so the time complexity of this code will be order of n, where n are the number of characters in your string. So now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.